Hello students, this is 12:42 a.m. on Monday 27 July and I have just solved this paper released by NTA, this NEET test 69, and this is a paper where majority of the questions are those which you have done them. There will be many questions that you would be directly ticking the answers because you have practiced them so much. So this is one of the lightest paper I can see. Not that light, but the question are so familiar that even the question might be tough, you could do that quite easily. There's one question, the answer to which I don't agree, and that question has already come maybe in the JEE main test or the NTA NEET test before, and there also the answer I couldn't agree with that. Otherwise all are good. I have regarded two questions as tough, 20 as easy, 23 as medium. I suppose again this is a paper where you should latch onto it. You can score the maximum here. So even for a student who's expecting some average scores and he is thorough with the syllabus, it should get 140 plus, and for a very good students it has to be 170 type scores here or greater than that. So it would be like that. So let's see what is in it. Plus one more thing, if you want the PDF of this test, you can fill in the type form I have attached in the description of the video. Those students who have already filled the type form in the previous test need not to do that. I'll send them directly without any formality now. Okay, so let's start it. The frequency for a series limit of Balmer and Paschen series are F1 and F3. If the frequency of the first line of Balmer series is F2, then the relation between F1, F2 and F3 is okay. So the Lyman Balmer Paschen, so if we do this like till infinity, okay, so this is 1, this is 2, this is 3, this is 4. So for the Balmer one, this is the first line 3 to 2, and this frequency is F2, and series limit would be like this one, this is F1, and the series limit for what we have Paschen is this one. So clearly what you can make out, this energy even involved in the F1 transition is equal to E2 plus E3. So because E is h nu directly, or HF, you can directly say F1 is equal to F2 plus F3, or you can write F1 minus F2 is equal to F3. So going by the relation, I'll go for option A. So it's an easy one for you. Next, the momentum of a photon of energy 1 mega electronic volt in kg meter per second would be. Okay, so for any photon, what the relation that we have, P is equal to E by C. So E is 1.6 into 10 to the power minus 13, and C is 3 into 10 to the power 8. So it would be in SI unit kg meter per second for sure. So now what we get, this is 1.3 by 6, that is 0.5, and this is 33. You can write 0.53 into 10 to the power what we have, 10 to the power minus 13, or 10 to the power minus 8, that is 10 to the power minus 21. So it is 5.3 into 10 to the power minus 22, or in one significant figures it would be 5 into 10 to the power minus 22 kg meter per second for sure. Next one, find the velocity of the cm of the system shown. Okay, so we have two masses 1 and 2. What would be the velocity? So what I can write, the VCM, let me have the pen, yeah, VCM is 1 kg into velocity I can write as 2 I cap plus 2 kg, its velocity I can write as 2 cos of 30 I cap minus 2 sin 30 j cap, because it is in fourth quadrant, divided by 3 kg 1 plus 2. So now what we have, I can do this is 2 I cap, and this will become cos 30 is root 3 by 2, so it becomes root 3 by 2, so it becomes 2 root 3 I cap. This is 2 to 4, sin 30 is half, so minus 2 I cap by 3 kg, or kg we can directly write it in meter per second. So this goes, what we have now, we have this, as per the given option, the velocity will be what I can make out. Okay, I've done some mistake. Oh, this is the grave mistake I did. It is j cap. Okay, so it cannot be cancelled. It was good there was no option like that. So what we have now, 2 plus 2 root 3 by 3 I cap minus 2 by 3 j cap. So going by the options, I'll go for A. So be careful, don't do such mistakes. Next one, a ball going with a certain velocity hits another identical ball at rest. If the plane is frictionless, collision is an elastic oblique one. Okay, the angle between the directions the ball move after the collision, you have remembered this. If you have an oblique elastic collision between two identical balls with one ball at rest, both will go perpendicular to each other, so angle would be 90 degree. So just recall this concept. This is given in your NCERT book also. So I'm just recalling it, like let's say like this one was going with velocity, let's say u. So what happens, this is the line of a common normal, so this gets the momentum here, so it will go in this direction with the component u cos theta, because it's a 1D collision you can treat, and in this direction its velocity will remain as it is, that is u sin theta. So it will go there, it will go there, and the angle would be 90 degree. That is what you have learned in that particular example. This is an important one. This happens in the snooker or the billiards, what you call. A disc, we had, okay, question number 4, okay. A disc initially at rest is rotated about its axis with uniform angular acceleration. In first 2 seconds, rotate angle theta, in the next 2. This is a very common question. I can directly make out it is 3 theta, but I'll tell you what happens for 0 to 2 seconds. For 0 to 2 seconds, what you will say, the angle turn delta theta is given as theta, that would be equal to half alpha into 2 square. Now for you have to calculate next 2. So first let me calculate 0 to 4. So 0 to 4, let's say theta plus theta additional, I can say that would be equal to half alpha into, that would be 4 square. So if I write that, what would be the theta additional? That is half alpha into 4 square, that is 16, and this is what we had, this was 2 alpha. So this will be 8 alpha minus theta. So 8 alpha would be, you can say 4 theta minus theta would be 3 theta, or there are many ways also you can do that. Next one. Car goes with speed 20 on a circular path of 100 meter radius. Its speed increases at a rate of 3, that means this is 80. The magnitude of acceleration at this moment, so 80 is 3 and AC would be v square by r, you all know, that is 20 into 20 upon 100, so it comes out as 4. So 1 is 3, 1 is 4, A would be equal to net acceleration because both are perpendicular. 80 square plus AC square, that would be 3 square plus 4 square, that is 5 meter per second square for sure. So go for option D. You can also find out the angle, it may x with velocity or with the radius vector, those type of things can also be find out. Next. So after 6, this is 7th. The resistance of a wire is capital R ohms. It is melted and stretched to n times its original length, its new resistance. Whenever it is melted, you know R is proportional to L square. How you do this? You write it as rho L by A, multiply both sides by L, you have rho L square upon volume. So because on melting we assume volume remains same, so R is proportional to L square, so this will become N square times R. This is the question that students do even in class 10th NTSC type examinations. Now the equivalent resistance between points A and B will be, okay, each is 15. So between A and B, first let me mark them out. Okay, so this is 15, so everything will be parallel to this 15, so answer would be less than 15, so these two are rejected. Now we are left with only two choices, 10 or 8. Now what to do now? So here, as per the diagram, it's tough to make out, but what I can see, it is not crossing, I suppose, or if it is not cross, okay, it is a junction, I can assume it to be O. Now due to the symmetry, what I can say, if I1 current goes here, I1 will go here. This is called input output symmetry. If I2 goes there, I2 will go there. That means at this junction no current will pass through, so you can open it up. So these 15 and 15 will be in series, these 15 and 15 will be in series. So 15 15, that is 30, and this 13 and 15 will be in parallel, so that between CD 13 to 15 upon 30 plus 15, that is 45. You do this, this becomes 10. So this becomes 10, so I am redrawing it. This was 15, this whole simplifies to 10, this is 15, this whole lot again 15, and that all will be again 10 here also, and this is A and B. So what you are left with, 15 15 10, that is 30, and 10 40, and 40 and 10 in parallel, so our equivalent would be 40 into 10 by 50, so it comes out as 40 by 5, it is 8 ohms. So go for option B. So again you have to just do this. You have done such question, I suppose, previously also, where the such junction things comes. When a 10 microcoulombs charge is enclosed by a closed surface, the flux through the surface is phi. Now another 10 microcoulomb charge is placed inside the closed surface, then the flux passing through the surface will be. So we know flux is Q enclosed upon epsilon naught. So Q enclosed is doubled, so flux will be doubled, that is for sure. So that will become 2. Now the next one, 10th. For a series LCR circuit at resonance, the statement which is not true is, okay, peak energy stored by capacitors, peak energy stored by an inductor. Okay, we will see to it. Average power is apparent power. Wattless current is 0. Yes, that is for sure. Wattless current is 0, because what we can say, the complete current would be the current through the resistor. Power factor is 0. No, power factor is 1, so I can go not true. I know D is definitely not true. For others I might need to check, but power factor is 1, so I know I'm not checking the A and B. You can check them. Next, 2-point charges, A is plus 3 nanocoulomb, B is 1 nanocoulomb, are placed 5 centimeter apart in the air. The work done to move charge B towards A by 1 centimeter is okay. So what we have, this is A, this is B, this is plus 3 nanocoulombs, this is plus 1 nanocoulombs, this is 5 centimeter away. Now to move it towards it by 1 centimeter, so the gap will become 4. So W external simply is U final minus U initial. So K, Q1, Q2 I take as common. It would be 1 upon 4 centimeter minus 1 upon 5 centimeter. So K, Q1, Q2, 9 into 10 to the power 9. Q1, Q2 would be 3 into 10 to the power minus 18. And if I do this is centimeter, it is 0.01, so it would be 100 by 4 minus 100 by 5 in SI units. So this is 25 minus 20, that is 5. 9 and 3, 27. 27 into 5 into 10 to the power minus 9. So 27 into 5, you know, is 135 into 10 to the power minus 9 joules. So it comes out as 1.35 into 10 to the power minus 7 joule. Go for it. Next one. In a certain region, uniform electric field, uniform magnetic field present in opposite direction, particle of mass m and charge q enters with velocity at an angle theta from the magnetic field. The time after which the speed of the particle would be minimum. Okay, so I definitely know speed is changing only by the electric field. Okay, so let's say this is the magnetic field B and it enters with an angle theta from it, and we know the electric field is in this direction, opposite, and it is a positive charge. So first of all, the electric field will be pulling it here. The component, this one, this V perpendicular, which is unchanged by E, it would be rotating it in a circle perpendicular to V and B, this plane. But this V parallel component will U parallel will definitely get reduced by this E. So the speed will be minimum when this component becomes 0. That means V parallel becomes 0. That would be equal to U parallel plus A parallel T, and that A parallel is due to electric field. So what I can write, V cos theta, and this would be negative, that would be equal to QE by M into T equal to 0. So T equals to MV cos theta by QE for sure. So I'll go for option C. So not that tough one, you have to just apply simple logic. Next one. Out of the following, the only correct statement about satellite is, satellite cannot move in a stable orbit in a plane passing through the Earth's center. Geostationary satellites are launched in the equatorial plane. Yes, this is the correct one. We always say geostationary satellites are always in the equatorial plane to exactly match the Earth's angular speed always. So let's say if you are living in a Delhi, you cannot have a geostationary satellite directly overhead of you, because that is not an equatorial plane passing through that particular point. So this is the point we teach in geostationary satellites. So that's okay. So this is a correct statement. No need to go further, you can check otherwise also. Next, rocket is fired from the Earth towards the Sun. At what distance from the Earth's center the gravitational force on the rocket is 0? Okay, so we have to take the effect of both. Basically you have to get the null point. That is a simple thing. This is Sun, this is Earth. You have to take, let's say this is MS, this is ME, and the distance, this is D you are given. So let's assume the distance from the Earth center, let it be x, and let's say this will become d minus x. So both field must cancel. So the field of the Earth is gme upon x square, this is gms upon d minus x whole square. So what we have, x upon d minus x, because x is smaller I can directly write that is equal to me upon ms under root. That is what we can write. So me upon ms under root, me is what, 6 in 10 to the power 24, that is 2 in 10 to the power 30. So if I do this, this comes out as root 6, and this would be 2, or I should write it as 3 only. Okay, better, I should write it as 3 into 10 to the power minus 6. That is x upon d minus x. So what we have, so x is root 3 into 10 to the power minus 6 into dd is 15 into 10 to the power 10 minus root 3 into 10 to the power minus 6x. So x will become 15 into 10 to the power 10 into root of 3 into 10 to the power minus 6 upon 1 plus root of 3 into 10 to the power minus 6. So this is going to be very, very small. It is approximately 1. So I can approximately go for direct product of this. 15 into I2, this is 10 to the power 7 into root 3. Root 3 is 1.73. So 15 into 1.73, if you will do, it would be approximately, what you can say, greater than 25, 26, 27 types things, plus this would be 10 to the power 8. So go for option A, going by the approximation of values are very far away. Next one. Black body of temperature T is inside a chamber of T0. Now the closed chamber is slightly opened such that the temperature of the black body and chamber remains constant then. Now this is the question they have asked in JEE Main, and I have told that this similar question has been asked in JEE, where they say it is maintained constant. So there is some slight difference in the language. If I go by the JEE question, because it is maintained constant temperature of black body, ideally what happens, the emission of the black body will depend on its temperature, and its temperature is same, so the emit energy will remain same. But because the chamber is opened, more rays are falling on it, so it will absorb more but emit the same, so the extra amount of absorbed heat has to be cooled down by some cooling arrangement. So the question is, then the black body will absorb more radiation? Yes. The black body will absorb less radiation? No. Will emit more energy? No. Will emit energy equal to energy absorbed by it? So I'll go for option A. There they have given option D because there's a language is slightly confusing. It is saying if it remains constant by itself, then the D will be same, but it cannot remain constant in that particular case, because you know the emission energy depends only on its emissivity, its area and its temperature. All three are same, so you cannot say that absorption will increase so emission will also increase in this particular case. Here you would be cooling it by some other arrangement, so I don't agree with the NTA answer here. Next one. CV and CP denote the molar specific heat capacities of a gas at constant volume and molar and constant pressure respectively then. Okay, so CV, CP denotes the molar specific heat. CP minus CV is larger. We know it is same for all, so it is wrong, it is wrong, it is wrong. CP by CV is larger for diatomic gas. We know diatomic gas CP by CV is 7 by 5. For mono it is 5 by 3, and we know 5 by 3 is greater. So it is larger for diatomic gas. This is also wrong. So CP minus CV. Okay, this is CP plus CV. I read it wrong. CP plus CV is larger for diatomic gas. Yes, because CV is larger, CP is larger. So B would be right now. So no need to go for there. I wrote it, initially read it at CP minus CV. So it is CP plus CV is greater for a diatomic gas. So B is right. Next one. Two identical containers A and B have frictionless piston. They contain the same volume of ideal gas at the same temperature. A has mass MA, B has MB. Now allowed to expand isothermally to double the initial volume. Okay. Now change in the pressure in A and B are respectively this and this then. This is again a question that has been asked in previous examinations. Now let's see what happens. Because volume is doubled, what you know, pressure will be halved. So what will happen? So the initial pressure, let's say PA, so PA by 2 will become delta P, while the PB by 2 will become 3 by 2 delta P. So from here what I can make out, I can directly say PA upon PB is basically what you have 1 upon 1.5. That is what I am getting. Okay, 2 by 3 or 1 upon 1.5. And you know pressure is what? nRT by V. V is same. So here the pressure ratio would be, they are at the same temperature. Temperature is also same, so that would be equal to Na upon Nb, and Na is what we have, and they have same volume. Okay, so that would be Ma upon molar mass M, that would be Mb upon molar mass M. Molar masses cancel, so Ma upon Mb comes out as 1 upon 1.5, or you can write it as 2 by 3. So by their logic, what we have, 3 Ma is 2 Mb. Go for option C. Next one. If a current is passed in a spring, you know, because it will be passed like this. So let's say it goes like this. So these two nearby will have attraction, so it will get compressed. So go for option A. Next. A conducting loop carrying a current I is placed in a uniform magnetic field pointing into the plane of the paper as shown. Okay, it is not shown, but it should be into the plane of the paper. Okay, then the loop will have a tendency to, what we'll see. Let's see this section. So because current is this, field is inside, so if you do dl cross b, this magnetic field force is basically outward, so it will try to expand it. So we'll go for option A. It will try to expand it. If you will see here, it will be like this, so at everywhere it would be acting normally outwards like that. Next one. A thin magnetic needle vibrates in the horizontal plane with a period of 4 seconds. The needle is cut into two halves by a plane normal to the magnetic axis of the needle. Okay, then the period of vibration of each half needle is approximately. So here what will happen if we take it as almost a bar magnet? So this is the axis, we are cutting it now here like this. So now each part will have half the length. So in this particular case, if cut it into n equal parts, time period becomes t by n. That's a direct result, but I'm telling you how it comes. We know initial time period is 2 pi under root of what we have, I naught upon, I naught is the angular momentum, moment of inertia upon mu naught b. Now if this was mu naught and this is I naught, now what it is, it will become mu naught by 2, and because I is proportional to what you say ml square, here m is half, l is half, so it is 1 by 4, so it will become I naught by 8. So if you do this, you will get this time period now would be equals to t naught by 2, so that is going to be 2 seconds. So you can directly remember, if you cut it like this, if it is n equal parts, time period becomes t naught by n. If you cut it like this, nothing happens, time period remains the same. Next one, the velocity of a particle is 0 at time t equal to 2 seconds then. So velocity is 0, that means displacement must be 0. No, that is not needed. Acceleration may be 0. Yes, it may be 0. Maybe word is possible, must not be 0. Velocity must be 0 for t greater than 2 seconds. We can't comment. Acceleration must be 0. That's wrong. So we'll go for option B as per the given choices. Next, if a vector A is given by this, then the angle subtended with the x-axis, what generally we write it as cos alpha, and we write it as ax by a. So direction cosines that we call it, this would be 4 square plus 3 square plus 12 square. That's a standard result. 144 plus 25, that is 13. So it is 4 by 13. So cos inverse, not 3 by 13, it is 4 by 13. So it is option number D, cos inverse 4 by 13. So it's an easy one for you. Next, a horizontal rod of mass 0.01 kg, length 10 cm is placed on a horizontal frictionless plane inclined, or not horizontal, inclined at 60 degree with the horizontal, and with the length of the rod parallel to the edge of the inclined plane. A uniform field is applied vertically downwards. If the current through the rod is this, then the value of magnetic field induction for which the rod remains stationary. So let's see, let the incline be like this, and let me draw some 3D style it. Let's say like this. You can imagine this is inwards, okay? So let's assume this is edge parallel, it is placed, so it would be placed like this. This is the rod. So we have this mg acting downwards. We had this normal acting normally, and to balance this we need some component along the incline, and the field is given downwards. So definitely what I will assume here, so let's say the current would be flowing like this. So it is L cross B. If you will do that L cross B, so it would be the force that would be coming out would be like this. This is BIL. So now this angle is theta, so if I make it, this angle will also be theta. So what I have, that component BIL cos theta must be equals to mg sin theta for the balance. So now what the value of B is, that is mg upon IL, that comes out as 10 theta. So what is mg? Mg is what you are given, 0.01 into 10, so that would be 0.1. I is 1.73, I can write it as root 3, and 10 theta is also root 3, so we are given a very good choice, that is 0.1, so it comes out as 1 Tesla. So you have to be very careful about imagining it, as it is not a good, it's not an easy question, it's a good question, it's not an easy one, especially for bio students. You have to be very careful to assume it like this. If you assume the rod to be like this, it cannot be in balance, because in that case the force cannot be like in the way to balance the forces that we require here. Next one, body is weighing 8 gram when placed in one pan and 18 gram when placed on other pan of a false balance. Okay, if the beam is horizontal when both the pans are empty, then the true weight of the body is, okay, so it's an interesting one. It weighs 8 gram when placed in one and 18 when placed on the other. So for the first case, let's say what I can say, right, mgl1 would be equals to 8g into L2. 8 I am taking in grams only, okay. In the second one, mgl2 would be equal to 18gl1, because now the L1 L2 arms will be changed because you have changed the pen. So let it be like this. This was L1 and this was L2. One time it is here, one time it is here. So what we can do now, so what we can do here, we can divide it. It goes. So what you have, L1 square upon L2 square is 4 by 9. So you have that L1 by L2 is equal to 2 by 3 for sure. So going in from the first equation, mg into what we can have, we can directly better to write it like m would be 8 times L2 by L1. So what is L2 by L1? 3 by 2. So 8 into 3 by 2, that is 4 3s are 12 gram. So the true weight is going to be 12 gram from this particular calculation. Again, it's an interesting question. Next, 65 copper turns into 66 copper if it is bombarded with. Okay, so 65 Cu to 66 Cu, that means no change in atomic number. So we cannot bombard with proton for sure. We cannot bombard with electron for sure. Definitely it has to be neutron because that number doesn't change. 29 I suppose is for copper. I might be wrong. I remember it as 29. If it is different, please forgive me. Okay, but that will remain same whatever it is. So it's the one that I'll go for neutrons. Next one. A radioactive element has a rate of disintegration 10,000 disintegration per minute at a particular instant. After 4 minutes it becomes 2500. You can directly say after 4 minutes it is becoming 1/4. So T half you can directly make out is 2 minutes. The decay constant per minute is now lambda. You have already know ln2 upon T half. So what we have, T half is 2 minutes. So that is 0.5 log E2. That is what I can write. So go for option B. That's an easy one. Next. Two simple pendulums A, B made to oscillate simultaneously found A complete 10 in 20, B complete 8 in 10, the ratio of the length. 10 oscillation in 20. So that means time period of A is 2 seconds, time period of B is 10 by 8. I can make out 10 by 8 means 1.25 seconds. So we know TV is proportional to root L. So TA upon TB would be equal to root of LA upon LB. So LA upon LB, what I can do, square it up. So 4 upon 1.25, better write it as 5 by 4 whole square. So that is 4 into 4 square by 5 square, 64 by 25. Go for option B. So again, not a tough one, this one. Coin is placed on a horizontal platform which undergoes vertical SHM of angular frequency omega. The amplitude of oscillation is gradually increased. Coin will leave contact. You remember this is a very common concept. Let's consider this platform. This is the mean position. As it goes up, the normal will decrease because it needs acceleration downward. So we say the normal minimum will act at the highest point. So what we write at the, let's say at this y equal to plus a, because acceleration would be omega square a downwards, what I can write, mg minus nmin would be equal to m omega square a at the highest point. So nmin comes out as mg minus omega square a, and to lose contact, for that this should become 0. That means g becomes omega square a. So omega becomes, okay, for an amplitude, so amplitude you are solving, so a becomes g by omega square. So this is a very common question, you all must have done this. So amplitude g by omega square, not g square by omega square. Go for option C. Next one. In an experiment on a photoelectric effect, the slope of the cutoff voltage versus frequency is found to be this, the value of Planck constant. So what we have, stopping potential you know is equal to h nu by E minus phi by E. So the slope is h by E. So h would be slope into E. So what you have, 4.12 into 10 to the power minus 15 into 1.6 into 10 to the power minus 19. So 16 2s are 32, 16 1s are 16, 19, 16 4s are 64, 65. So what do you have, 6.592 into 10 to the power minus 34. That is what I am getting from here. So go for option A. That is the most appropriate one. Next. A radio transmitter operates at a frequency 880 kilohertz and a power of 10 kilowatt. The number of photons emitted is, what I can say, the power would be number of photons per second into energy of single photon. So the number of photons would be power, that is 10 into 10 to the power 3. Single photon's energy is h nu, that is 6.63 into 10 to the power minus 34 into 880 into 10 to the power 3. So this goes, this goes, this goes. So what we have, take 10 to the power 34 above, it would be 88 into 6.63. So now you can make out 88 into 6.63. You have, let's say whatever it would be coming out, it would be 500 plus something. So we have something upon 500 plus something. So it would be 1 point something into 10 to the power 31. That is what I can make out from the order. So I will directly go by the order. So order calculations you can do because orders are vastly different. So you can do now. Next. Vessel completely filled with water has holes A and B at depth h and 3h from the top. The hole A is a square of side L, B is a circle of radius r. The water flowing from per second is same, then L is equal to, then you can directly make out. So that means A1 V1 must be equals to A2 V2. That is the volumetric flow rate. So first one, hole A, area would be L square, velocity would be root 2 GH. For the second one, it would be pi r square, and the velocity would be root 2g into 3h. So what you need, L is equal to. So what we have, so what we can do here, let's say L to the power 4 2gh square both the sides, that is pi square r to the power 4 6gh. So gh goes, so L to the power 4 is pi square r to the power 4 into 3. So L would be 3 to the power 1 by 4 pi to the power 2 by 4 r to the power 1. So what we get now, so r pi half 3 to the power 1 by 4, go for option C. Next one. The length of a metal wire is L1 when tension is T1, L2 when tension is T2. We have done this many times. You all remember it would be T1 L2 minus T2 L1 upon T1 minus T2, or T2 L1 minus L2 T1 upon T2 minus T1. Again, I am telling you, this L1 would be original length plus extension, L2 would be original length plus extension, and we know extension delta L1 would be equal to T1 L0 upon AY, and delta L2 would be T2 L0 upon AY. Divide them and solve using delta L1 equals to L1 minus L2, and this is L2 minus L0. So do this, you will get the result. Next one. We have two lenses of 10 diopter minus 5 diopter placed in contact. Where should an object be placed from the lens so as to obtain a virtual image of magnification 2? So because they are placed in contact, the power of the combination, because directly we can add, would be plus 5d. So it is plus 5d, that means f of the combination would be, I can write it as, in centimeter it would be 100 by 5, that is 20 centimeter positive, that means it is a convex lens. Now to obtain a virtual image of magnification 2, that means the object must be between pole and focus, so it should be between 0 and 20 with a negative sign for sure. Now to check them, what I can write, magnification, you have to write it, the magnification what we write is v upon u, and we using 1 by v minus 1 by u equals to 1 by f. V you know is equal to uf upon u plus f, so that becomes v by u is f upon u plus f, that becomes 2. So 20 upon u plus 20 equals to 2, so it is 10, so 10 is u plus 20, so u comes out as minus 10 for sure. So go for option D, you can do like this. Next one. Point object O is placed in front of a glass rod having a spherical end of the at the radius of 30 centimeter. The image would be formed at, okay. So we had this as n1, this has n2, applying the formula n2 by v minus n1 by u equals n2 minus n1 by r. What is n2? Glass, you are given the value? No, you are not given the value. So I am taking 1.5 standard data. V I am solving 1 upon minus 15, n2 minus n1 is 0.5, radius would be plus 30. Okay, the radius is plus 30. So 1.5 by v would be 1 by 60 I can write, and this would be minus 1 by 15, it would be 60, it would be minus 3 in simplifying. So v comes out as 60 into 1.5 upon 3 with negative sign, so this is 20 into 1.5, that is minus 30. So 30 centimeter left from the pole, so go for option A here. They should have given the data of n, but okay, we can assume for glass. Next. If a body of mi 2 kg meter square revolves about an axis making 2 rotations per second, then its angular momentum is, what we have, L is equal to I omega, I is 2, omega is 2 rotation per second, means 4 pi radians per second. So that is 8 pi, that's an easy one, very easy one I can say. Next. Circular disc, radius r, rolls without slipping along the horizontal surface with a constant velocity v0. We consider a point A on the surface of the rim, then the acceleration of point A is, okay, on the surface, so it could be any point now. And consider any point. What happens, because this point is always changing the velocity, so the acceleration, because in frame of CM I can see, in frame of CM it is going angular, it is going pure circular motion, so its acceleration would be directed towards the center, and we directly write acceleration of A would be acceleration of A with respect to CM plus A of CM, and here A of CM is 0. So acceleration of A with respect to CM, it is changing in direction because center's direction is changing, but its magnitude will remain constant. So its magnitude remains constant, direction will constant in magnitude, sorry, not in direction. Direction keeps on changing, but the magnitude will remain the same. Good question. Next. Forward bias characteristics of a PN junction diode is used in which of the following devices? Voltage regulation, no, that is Zener in reverse. Oscillator, rectifier circuit, solar cell. Solar cell also we don't use it. Oscillator, we don't use diode there. In rectifier we use this forward bias because we know it conducts only in one time, so we can say only the rectifier one we can take here. Next one, the logic circuit shown as input A and B, pick out the correct waveform. Okay, so first of all let me check. Let's say if it is 0 0, it would be 1 1, and this gate, you remember this is the NOR gate, 1 1 OR gives 1, so NOR will give 0, so 0 0 should give 0. Similarly 0 and 1, 0 and 1, this will become 1 0, still give 0. Similarly 1 and 0 will also give 0, and last option 1 1, that will give me 1, so it is an AND gate. So check it, so only this is 1 1 and this is 1 1, so only 2 times it should be 1. So going by the logic, it would be option A, it's simply an AND gate, so you can directly do that. So it is simply an AND gate that is being made here. Next one, the RMS speed of hydrogen molecule at certain temperature is V. If the temperature is doubled and hydrogen gas dissociates into atomic hydrogen, the RMS speed is. So what we write, VRMS, we write as root 3 RT by M. So temperature has doubled and it has dissociated, so mass has become half, so it is the factor of 4, so it will become 2, so it will be 2V because root 4 is 2. So again an easy one, you have done such profiles I suppose. Let C be capacitance, V be the potential, then the dimensional formula CV square, you know energy is half CV square, that is energy. I always say remember ML2T minus 2. So ML2T minus 2, go for option D, that's an easy one. Next one, beam of light from a distant source falls on a single slit 1 mm wide and the resulting diffraction is obtained on a screen 2 meter away. Distance between the first dark fringes on the either side. So the first dark fringe you know comes out as lambda L by A, so the gap between them would be 2 lambda L by A, that is the width of central maxima, and I think this question as we have done before in some NTA test, that L is 2 and that is 1 mm 10 to the power minus 3, so do it carefully. So what we have, 10 to the power minus 3, this becomes 10 to the power 5, so it is 10 to the power minus 4, 6 2s are 12, 2s are 24, so it comes out as 2.4 mm. So I'll go for option D, that is the correct one here. Now the next one, a 2-slit Young's interference experiment is done with monochromatic light of 6000 angstrom. These slits are 2 mm apart. The fringes are observed on a screen placed 10 cm away from the slits. Transparent plate of thickness 0.5 mm is placed in front of one of the slits. It is found that the pattern shifts by 5 mm. What is the refractive index of the transparent plate? So if you directly remember that formula, that shift we directly write as n minus 1 into T d by d. That is the standard result that we use. So that shift 5 into 10 to the power minus 3, n we are solving, T is 0.5 into 10 to the power minus 3, d is 10 centimeters, so I should write it in also centimeters, so it will cancel out. So now everything is in SI1 or in the same units. This goes cancel, 0.5 by 0.2, so this becomes 5, I can cancel it. So n minus 1 comes out. Now what I can write, that 5 is cancelled, n minus 1 is 0.2, so n comes out as 1.2 here. So go for option A for this particular one. Next one, open organ pipe, length L vibrates in fundamental mode, the pressure variation is maximum is. Okay, so that is the reverse of the displacement, and the open pipe, this is what we can say, this is a displacement antinode, this is displacement antinode, so it is pressure node and it would be pressure node, so both ends would be the pressure node here. So what will have the pressure variation, pressure node, here the variation will be least, and in the middle it would be pressure antinode. So pressure antinode maximum variation will be at the middle of the pipe for sure. Okay, so just remember this, it is reverse of the displacement node and antinode. Next, transverse wave along a string is given by this. Okay, find the acceleration of particle located at 4 cm at 1 second. Okay, 4 cm at 1 second. First let me check its position. Y at 4 cm and 1 second, what will be 2 sine of, what I can write, 2 pi 3t minus x, that is 3 minus 4 plus pi by 4. So what may I have, 2 sine, that would be 2 pi plus pi by 4, that is sine of pi by 4, that is it. What we have, it would be root 2. That means in SHM it would be at a by root 2 position I can make out. And by the going by the logic of acceleration, because it is positive, acceleration is minus omega square x. So omega from here you can make out that is 6 pi x is root 2, so minus 36 root 2 pi square centimeter per second square. So go for option C using the analogy of the SHM, because every particle executes SHM when the wave propagates. Next, the last one we are now. Ideal spring with spring constant K is hung from the ceiling and a block of mass m attached to the lower end. If the mass is released with spring initially unstretched, the maximum extension, you all remember equilibrium extension is mg by k and maximum extension is 2mg by k. And how to do this? Let me tell you again. Let's say this was the position, this was the initial position, spring was in its natural length and the speed is 0 here. So at the maximum elongation, again the speed will become 0, let it be x max. So going from here to here, taking the system as a spring plus block plus earth, what I can say, kinetic energy change is 0, so loss in gravitational energy is gain in spring energy. So loss would be mg x max and it would be half k x max square. From here you will get that x max equal to 2mg by k. So this was today's paper, I suppose, not that tough one. You will find it in the initial analysis also. Thanks for watching. Please keep sharing the channel, keep giving in your comments, and I am also planning to have a short course covering some 8 to 10 topics in physics. I'll be sharing those details very soon to all of you. Keep watching this space.